all about aldol. We'll look at a series of problems having to do with the aldol reaction, sometimes referred to as the aldol condensation. So let's look at the aldol as a synthetic method for the preparation of alpha-beta unsaturated ketones and aldehydes. So let's imagine that we're presented with a synthesis problem. Here's the carbonyl. The position next to the carbonyl is the alpha position, and then comes beta after alpha. So this is an alpha-beta unsaturated in the sense that it has a pi bond between alpha and beta. And in this particular case, it's a ketone. So retrosynthetically, we should think about making this compound using an aldol reaction. So just like when we examined the Diels-Alder reaction, we said that a cyclohexene ring was a cue that we should think about making that structure using Diels-Alder. If you see an alpha-beta unsaturated ketone or aldehyde, think about aldol. So the question for you then is, do a retrosynthetic analysis on this alpha-beta unsaturated ketone and see if you can break it down ultimately into two components that will carry out an aldol reaction with each other to give ultimately this alpha-beta unsaturated ketone. Okay? So go ahead and try to do that in a step-by-step manner. Press pause, give it a try, and then come back and check your work. Well, if you're kind of stuck, let me give you a hint. The thing that comes right before the final alpha-beta unsaturated carbonyl product will be the beta hydroxy ketone. Remember that the beta hydroxy ketone will undergo loss of water to give the final alpha-beta unsaturated product. So if you were having a hard time giving the retrosynthetic precursor of your final target compound, maybe that hint will be enough to get you started. So let's take this back then. Here's the alpha carbon. Here's the beta carbon. And what I need is a hydroxy group on the beta position. So this is a beta hydroxy ketone. That would be the precursor to the final product. And then continue here. Think about what is the bond that is made in the course of an aldol reaction. What is the key bond that an aldol reaction makes? And use that information to work backwards in the opposite direction. The key bond that is made in an aldol reaction is the carbon-carbon bond between alpha and beta. So in terms of retrosynthesis, we would think of it in this way. It's convenient sometimes if you're thinking retrosynthetically to imagine the retroaldol process. So let's imagine, we can do aldol reactions either under acidic conditions or basic conditions. But imagine that we do this in acid so that we could have a proton on the carbonyl, for instance. Can you push the arrows for the retroaldol reaction? So in the retrosynthetic direction, we need to do a retroaldol. There will be 3 arrows for retroaldol. Start your arrow pushing on the beta hydroxy group. Okay, so we start here, go there, break this carbon-carbon bond, and then come out onto here. All right? So maybe if you haven't gotten to the next set of compounds in the retrosynthetic analysis, you can pause the video and see if you can follow those 3 arrows through in terms of what my starting materials will be. So over here, I have now disconnected into two components. Okay. So here is one component. This is an enol. And then the other component looks like this. So now I do have two pieces that I can put together to give this beta hydroxyketone. This is an enol. This here, see if you can identify what in the heck is this. This is a protonated ketone. So we're almost there. We're almost to the starting materials for this aldol condensation. You just need to specify where did this enol come from and where did this protonated ketone come from. So see if you can do that. Well, let's start with this enol. The enol came from tautomerization of the corresponding ketone. The ketone would just have this hydrogen not on the oxygen, but on this carbon right here. And so this ketone, when enolized, would give this enol. And then this protonated ketone, well, what ketone did it come from? It came from that ketone right there. So the final part of this question is, what is the relationship between this molecule that we're going to use for a synthesis of the target compound and this molecule right here? All right, so what are those to each other? These are one and the same. So this would be a pretty reasonable aldol condensation then, because you would use two identical components. You would treat these with acid catalysis. You would do the aldol condensation via this enol and this protonated ketone. That would give you the beta hydroxyketone. The beta hydroxyketone would undergo dehydration, and you end up with the alpha beta unsaturated ketone that we wanted. Be sure that you can write a mechanism so that if you were to take this ketone and treat it under acid catalyzed conditions, be sure you can write a mechanism that takes you all the way through the forward direction. Really, the conditions for this would be fairly simple. You would start out with these starting materials, treat this with H+, and then maybe you would need to heat this up a little bit, okay? And then ultimately go through to the final product.